So hello everyone and welcome to this third Numa TV session on iOS development. In the last 2 weeks, we have started with important topics like auto layout with adaptive layout and also saw the basics of the Swift syntax. Today, we're going to explore some other very important paradigms in Swift programming, which is object-oriented programming. And we're going to start with a small presentation, and we will then continue but with building an awesome little text-based space game, which is written purely in Swift. So let's get right started. So here we go. And what you're able to see here is a world seen by an object-oriented programmer. You will notice some interesting terms like singleton or view controller, like the remote control in the lower left corner, which an object-oriented programmer might call an entertainment provider view controller, or at the door, a visitor monitor interface, or an indoor session initializer. These are all terms that are used within object-oriented programming. So what does object-oriented programming mean, and what do we have to deal with in that respect? So let's start with the fundamentals right here. So object-oriented programming is actually all about classes, properties, methods, and functions, and objects. And what does that mean? Let's have a look at some cars, which are all kind of objects. And objects do have properties, and they can have functions or methods. These are two viable ways of calling actually almost the same thing, but we will discover the difference later. So let's discuss those cars. They are different in color, but they have some things in common, like the number of wheels or their basic functionality, like accelerating or braking. So if we were to think about those properties a little more in detail, then we could get a description of a car. And we could say that a car is made of a number of wheels. It has a specific color, it has a specific amount of horsepower, and there is, of course, a type, like sometimes it's a convertible, sometimes, for example, it's an SUV. And those things, this is what we call properties in object-oriented programming. And then let's also have a look at what a car can actually do. So a car can accelerate, it can brake, it can play music, or for example, now cars like Tesla do have autopilot. And these are all functions or methods of a car. So if we have a look at all of them together, like the properties on the left side and the functions or methods on the right side, then we have something that in object-oriented programming, or OOP, it's also called that way sometimes, if we have that, we have kind of a blueprint of a car, because that's what a car is made of. It's made of a number of wheels, of a color, and different methods like accelerating, and so on. So, and this blueprint is actually called a class. So this is very important, and we've already covered three very important terms. Now, what is an object really? And an object is nothing else but a so-called instance of a class. And so we have different instances here of the same class car, but with different properties, but mostly the same functions. Different properties like color green, color red, color black, or color blue, and they do have different amounts of horsepower, of course. So let's recap that for now. So let's see. A class is composed of properties and functions or methods. And the class is like a blueprint, which means that our objects are instances of this blueprint. And if we are talking about the implementation in code, then this would look something like this. We already saw how we can create constants. But to create an object of a class, you would write, for example, a super SUV constant. And to create an instance of our car class, we simply write car and a pair of parentheses. And then to access the different properties of our car object, super SUV, we simply use a dot and write the property right next to it. And then we can use an equal sign to assign different values, like the type SUV, or the color, which is black in this case, or also bool values or different kinds of values. And so this is how we would implement an object. And now there are also other different paradigms in OOP, or object-oriented programming, that we have to talk about, which is first of all encapsulation, which means that classes provide methods like break. You don't have to know exactly what break really does. You can simply call the method and the card does it. So the same thing it is with its properties. We don't exactly need to know what properties our break function really accesses, but we can use it. And this is encapsulation. Sometimes we want to make excuse me. Sometimes people get frogs in their throats. Sorry about that. So sometimes we want to make methods publicly available to us as developers or other developers in our team. And sometimes we want to keep it private in our class and only use it within that specific class. And that's called encapsulation. Another paradigm is inheritance, which means that we can create subclasses which inherit properties and methods of a superclass. And this goes hand in hand with the concept of polymorphism, which means that you can, if you subclass a superclass, then you can add more and unique properties and methods to that subclass. But we will see that abstract concept in action in later sessions as well. So far with this presentation and a small overview about object-oriented programming, let's now have a look at what we are going to create in this lesson. So let me bring up Xcode for you, and I'm going to demo to you what we are going to see right here. So here we go. This is going to be our application, which is a console application. This is the only time we're going to build console applications, but in every programming lesson, there must be at least one console game. At least that's kind of tradition. So let me run that for you. And let's have a look at the console here, the console output. And I should actually also start the game. So let's do that again. So what we have here is a simple console output. It says, welcome to the solar system. There are 8 planets to explore. What's your name? So I can simply enter my name here right in the console, press enter. And now it says, nice to meet you, Brian. My name is Eliza. I am an old friend of Siri. Let's go on an adventure. Shall I randomly choose a planet for you to visit? And now I can decide by either write Y for yes or N for no. I say no, I don't want this randomly chosen. I want to specify it myself, and I would go maybe for Earth. And simply type in Earth, hit enter, and then it says traveling to Earth, and we arrived at Earth, and there is something very familiar about this planet. And we have a question in the comments I see at the moment, and you say, you thought encapsulation means private and public, and it's exactly actually what it means. It means that we can give access to specific methods only to us within our class itself. We're going to see that in the example later on, and also there is going to be a publicly available method like the start function that we can see right here. But we will come to that, and you will see how we use public and private in that respect. And this is really important too, especially if we are working on larger projects and on projects where we work with different developers. And one of the best examples is actually UIKit or all the frameworks by Apple, since there are only so much functions publicly available or methods publicly available. So let's dive right into this example and start a new Xcode project. I'm pressing Command-Shift-N on my keyboard. I'm going to choose now that window for